there, Math Hoppers. In this video lesson, we are going to go over horizontal asymptotes. And just like vertical asymptotes, we have seen horizontal asymptotes in Algebra 2 and even Algebra 1 before. We just haven't done anything with them up until now. Again, probably trying to avoid mentioning them, hoping they would go away. So where have we seen them? We have seen them with rational functions. Remember, a rational function is simply a function in the form of a fraction where the numerator and denominator are expressions. And the most basic form was f of x equals 1 over x. We would graph it from a table and it would look like this. And even though we never mentioned it and we never drew it in, there was a horizontal asymptote at y equals 0. Just like there was a vertical asymptote at x equals 0 that we talked about in a previous video. But unlike vertical asymptotes, horizontal asymptotes are not as clean and black and white. Remember, vertical asymptotes, the graph never crossed them. They were a vertical line, you did not pass it. Horizontal asymptotes, not so clean. Horizontal asymptotes are a bit different than vertical asymptotes in that they tell us the behavior of the function at the extreme values of x. So they're not really that none shall pass line like vertical asymptotes are. Horizontal asymptotes, okay? We saw vertical asymptotes. Horizontal asymptotes, whole nother ballgame. Vertical asymptotes were super nice. They were vertical lines that the graph of a function never crossed. Horizontal asymptotes, they don't play like that because they only tell you what's happening at the ends of a function. So let's look at one. Here's the graph of 2x plus 1 over x squared plus 1. We see pretty clearly that this graph levels off towards y equals 0, right? So we can see a horizontal asymptote at y equals 0. If we look right here, we would see this y equals 0 right there, okay? But we also see something really weird happening. This graph crosses y equals 0. That doesn't happen with a vertical asymptote. But here we have a horizontal asymptote and the graph clearly crosses it. And again, that's because horizontal asymptotes are different. They tell you what's happening at the extreme values of the function. What do I mean by that? Well, as x, and if we don't know what this mathematical language means, let's learn it now. X approaches, that's what this right-hand arrow means. As x approaches infinity, the graph, or f of x, or the function, approaches 0. And that's clearly what's happening. To the right of 0, as the function gets closer and closer and closer, or as x gets closer and closer to infinity, the function gets closer and closer to 0, never crossing it. And it appears the same thing happens on the left-hand side. So let's see the rule. As x approaches negative infinity, remember, x approaching negative infinity, the function approaches 0. And again, true. The function stays below 0 to the left of 0, never crossing it. Getting closer and closer, the closer x gets to negative infinity. So let's look. There are 3 different rules for horizontal asymptotes. Let's just look at the patterns, and at the end of each pattern, I promise I'll tell you the rule. Okay, let's look at one that looks pretty similar to the one we just saw. Pretty clearly, we have horizontal asymptote at y equals 0. The graph appears to be leveling off towards that horizontal y equals 0 line. So what's the function? This is f of x equals 4x divided by x squared plus 2. All right, one function's not enough to make a rule. Let's look at one more. Here is another function, again, appears to level off at y equals 0. But again, it crosses y equals 0, but clearly has that horizontal asymptote that's leveling off towards y equals 0. And what is this function? This is f of x equals 2x plus 1 divided by 3x cubed plus 1. So we can see in this function, we have a linear over a quadratic. Here we have a linear over a cubic. I don't think the rule has anything to do with the fact that there's a linear in the numerator, but if you're looking at the degrees, the degree for both numerators is lower than both denominators. So let's see the rule. In rational functions, f of x equals ax over bx. If the degree in the numerator is less than the degree in the denominator, the horizontal asymptote is y equals 0. Think about this. This is the one we introduced the lesson with. This is the one we've seen before. The parent function y equals 1 over x had a horizontal asymptote at y equals 0, and sure enough, 1 is 1 times x to the 0 power, and x is x to the first. So it had a lower degree in the numerator than in the denominator. All right, so what should we conclude about this? Here's my rule. Here is my function. For sure, 4x over x squared plus 2 has a horizontal asymptote at y equals 0. And the same for 2x plus 1 over 3x cubed plus 1. Okay, so that's one rule down, 2 to go. Well, this one looks different. We appear to be leveling off over here at y equals 4. That's where I would place my horizontal asymptote. And that's where we have a horizontal asymptote. So let's look at another function. All right, this one appears to be somewhere between 1/2 and 1. I would put it at 2/3 or 3/4, somewhere in there, somewhere less than 1. Let's see where it is. There's our horizontal asymptote. Okay, to figure these out for sure, let's look at some functions. Here we have f of x equals 4x squared over x squared plus 2. Remember, we kind of put that horizontal asymptote at y equals 4. So what's our other function? F of x equals 2x cubed plus 1 over 3x cubed plus 1. So we looked at the degree in the numerator and denominator last time, so let's do that again. Degree of 2 here, degree of 2 here. Now we don't have degrees of 2, but again we have matching degrees. We have a cubic in the numerator and a cubic in the denominator. So what does the rule tell us? The rule tells us if we have a rational function, a of x over b of x, and the degree of a of x is equal, so the degree of the numerator is equal to the degree of the denominator, then it is simply the horizontal asymptote is the ratio of the leading coefficients. It's really no nice short way to write this. You kind of have to write the horizontal asymptote is y equals the leading coefficient of numerator over the leading coefficient of the denominator. So let's see what we're talking about. Leading coefficient here is 4. Leading coefficient, there's no number here. That tells us it's 1. 4 over 1 gives us a horizontal asymptote of y equals 4. Now remember, for this one, we kind of had to estimate, right? We couldn't really tell where that was. But now looking at the leading coefficients, I can see leading coefficient of 2 over leading coefficient of 3, telling me my horizontal asymptote is at y equals 2/3. Okay, one more rule to go. All right, that function does not appear to level off horizontally anywhere. I can't see it, I can't estimate it, can't do anything about it. Let's just look at the function. F of x equals a 4th degree over a linear, so x to the 4th minus 3x squared plus x over x minus 1. Let's look at another one. Again, that does not appear to level off horizontally anywhere. We have f of x equals x squared minus 3 over x plus 1. And I couldn't tell you where there was a horizontal asymptote in either of those functions. And that's good, because notice the degree in the numerator is larger than in the denominator in both of these. And when the degree in the numerator is greater than the degree in the denominator, there is no horizontal asymptote. And let's think about this. If I gave you x cubed, y equals x cubed over x, that would simplify to y equals x squared, which is a quadratic, which is not a rational function, which doesn't have a horizontal asymptote. So if your degree is higher in the numerator than the denominator, essentially you don't have a rational function, so you don't have a horizontal asymptote. But that doesn't stop me from thinking something weird is happening in this second function. Sure, this first function, nothing's happening. It's really weird. But this looks like I can almost put a diagonal asymptote in it. And I notice it's a little different. This is x to the 4th over x. So there's a big separation in degrees. Here, this is x squared over x. The separation is only 1. And let's see if we can come up with a rule for that. There's no horizontal asymptote there for sure. No horizontal asymptote here for sure. But it does look like something's happening. If the degree in the numerator is exactly 1 more than the degree in the denominator, there is a different type of asymptote, and we call it a slant asymptote. Okay, it looks like a diagonal. Remember, we kind of pointed it out here. So it's called a slant asymptote. It only happens when the degree in the numerator is exactly 1 more than the denominator. And we find it by taking the numerator and using either long division or synthetic division and dividing it by the denominator. So let's see what this one would look like. If we took x squared minus 3 and divided by x plus 1 and ignored any remainder we got, we would get a slant asymptote of y equals x minus 1. And it would fit right in there where we thought a diagonal asymptote would be. You normally don't learn slant asymptotes until you've learned long division of polynomials or synthetic division of polynomials, but by now you should have. So if your teacher's asking if there's no horizontal and there's no vertical, please mention if there's a slant. There will be a slant if the degree in the numerator is exactly one more than the denominator. All right, let's review the rule for horizontal asymptotes and we can call it a lesson. Remember, rule number 1, if the degree in the numerator is less than the degree in the denominator, then your horizontal asymptote is y equals 0. And just think about that parent function, y equals 1 over x. Horizontal asymptote, y equals 0, you've known about it forever. If the degree in the numerator equals the degree in the denominator, then you have to look at the ratio of the leading coefficients. It's the leading coefficient of the numerator over the leading coefficient of the denominator. And the easiest one of all, if the degree in the numerator is greater than the degree in the denominator, there is no horizontal asymptote. Remember, y equals x cubed over x is a quadratic, not a rational function. Okay, if you are working with asymptotes of any kind, and you have trouble with them, you're working on classwork, you're working on a homework, you're studying for a test, if you're going through Math Hop lessons, you should be subscribed to our YouTube channel because it exists for you. Submit your homework questions, submit your questions for your test. We will make a custom video solution and help you out. Until next time, Math Hoppers, take it easy.